Now I am discussing about topic mathematical morphology. First we are going to the introduction part. Mathematical morphology is a branch of image processing which arose in 1964. The word morphology denotes branch of biology that deals with the form and structure of animals and plants. In mathematical morphology is a tool for extracting image components that are used full in representation and description of region shapes such as boundary, skeleton and convex skull. That is, in simply, morphology is generally concerned with the shape and properties of object. It is used for segmentation and feature extraction. The basic two operations used in morphology are erosion and dilation. The language of mathematical morphology is set theory. As such, morphology offers unified and powerful approach to numerous image processing problems. Sets in mathematical morphology represents object in an image. In chapter 1 we are discussing preliminaries, that is the basic definition, union, intersection, complement, difference. First, union of two sets I am denoted by C equal to A union B, that is set of all elements belonging to either A or B. The intersection of two sets is equal to D equal to A intersection B, which belongs elements belonging both A and B. Complement of a set A is a set of all elements not containing A, that is set A equal to set of W such that W does not belongs to A, that is complement. And the difference of two sets A and B is a set of elements that belonging to A but not in B, that is A minus B is equal to set of all W such that W belongs to A when W does not belongs to B. The basic. Next we discuss the definition of reflection. Reflection of a set B denoted by B cap is equal to set of all W such that W is equal to minus B for some B belongs to capital B. Next, translation. Translation of a set A is equal by point set Z is equal to ordered by Z1 Z2, that is set of all C such that C equal to A plus Z for some A belongs to capital A. These are the basic terms used in morphology. This figure represents the reflection and translation of A by B. Next, we discuss some terms used in topic. First one, image preprocessing. Image preprocessing is the technique of enhancing data images which involves removing low frequency background noise or normalizing the intensity of the individual particle images, remove reflection and masking portion of images. Next, image segmentation. Image segmentation is the process of partitioning a digital image into multiple segments. That is, the goal of segmentation is to simplify or change the representation of an image into something that is more meaningful and easier to analyze. Next one, gray level image. A gray level image is simply one which only colors are shade of gray. The value between the gray level images are 0 and 255. Next, pixel. Pixel is the word we commonly use in our topic. Pixel is the smallest unit of a digital image or a graphic that can be displayed and represented on a digital display device. A pixel is a basic logical unit in digital graphics. A pixel is also known as picture element. Next, the term binary image. A binary image is a black and white image where each pixel value is either 0 or 1. The value 0 represents background or black and the value 1 represents the foreground or white. Next, thresholding. Thresholding is a process of creating black and white image out of a grayscale image by setting exactly those pixels to white whose value is above given threshold, setting other pixel to black. It is the simplest method of image segmentation. Grayscale image by thresholding can be used to create binary images. Next, the important definition, structuring element. Structuring element are the basic term that we use. Structuring element is small image used to prop the image under study. The center of structuring element is typically marked. For a computer implementation, structuring element should be a rectangular array. This is done by appending smallest number of background elements to structuring element to form a rectangle. That is, in simply, what is meant by structuring element is the number of pixels added or removed from the object in an image depend on the size and shape of the object used for process the image. In image processing, the number of pixels added or removed from the object is defined by the shape and size of structuring element. Next, fit, hit and miss. First, what is hit? When all the pixels in the structuring element cover the pixel of the object, we call it fit. When at least one of the pixels in the structuring element cover the pixel of the object, we call it hit. When no pixel in the structuring element cover the pixel of the object, we call it miss. Chapter 2, binary morphological operators. There are 5 binary morphological operators we are discussing. First one, dilation. Second one, erosion, opening, closing, and hit or miss transformation. First, we are discussing what is binary dilation. In binary morphology, dilation is a translation invariant operator equivalent to Minkowski addition. That is, let A and B be two sides in Z square. Dilation of A by B denoted by A dilated B is equal to A set of all sets such that B cap intersection A not equal to 5, where B cap denote the reflection of B. That is, this equation is based on an obtaining the reflection of D about its origin and shifting this reflection by Z. The direction of A by B then it is set of all displacements such that B cap and A overlap by at least one element. Based on this interpretation, we can write A dilated B is equal to set of forces such that B intersection A contained in A. In figure 1.3, we can see the original image and the dilated image. That is, in dilation, dilation actually fills the holes and it smoothes the object boundaries. That is, then we can see the difference, what is original image and difference between original image and dilated image in 1.3. Next example 1.2, let x is equal to 1 0 1 1 1 2 2 2 0 3 and 0 4, and let b be the structuring element. Here use 0 0 and 1 0. Then dilated x dilated b is equal to 1 0 1 1 1 2 2 2 0 3 0 4 2 0 2 1 2 2 1 3 1 4. That is, let x denote the black. Next, properties of dilation. First one, dilation is commutative. That is, A dilated B is equal to B dilated A. Next, associative. A dilated B plus C is equal to A dilated B plus C. Invariant to translation. That is, A H dilated B is equal to A plus B dilated H. Dilation is increasing. That is, if A containing B implies A dilated C containing B dilated C. Or eccentricity, if 0 belongs to B, then X containing X dilated B. These are the properties of dilation. Next, binary erosion. Let A and B be two sets in Z square. The erosion of binary image A by the structuring element B is defined by A minus B, that is equal to set of forces such that B is contained in A. In erosion, it removes the pixel from the boundary. That is, A minus B, the erosion B is equal to set of forces such that B contained in A, where B is the translation of B by the vector Z. In words, this equation indicates the erosion of A by B is a set of all points such that B translated by Z is contained in A. In example 1.6, we can discuss the erosion process. That is, let x is equal to ordered pair 1 0 1 1 1 2 0 3 1 3 2 3 3 3 and 1 4. That is, the figure x represents the ordered pair and B be the structuring element. Then the x minus B, we can see that the shape, it removes the pixel from it removes the pixels. That is, when we can see that the number of elements and decreases when after erosion process happens. And next, in 1.7 example, we can see that the left with the original picture, and after the erosion we can see that the shades are decreases because of we know erosion removes the pixel from the boundary. Next, properties of erosion. Erosion is not commutative. that is A eroded B, the A minus B not equal to B minus A എന്ന് പറയുന്നു. Erosion is translation invariant, that is A erosion B is equal to A erosion B H, and erosion is anti-extensive. If 0 belongs to B, then A erosion B contained in X. Next, duality relationship between dilation and erosion. Dilation and erosion are duals of each other with respect to such complementation and reflection. That is, A erosion B complement is equal to A complement dilation B complement, and A dilation B complement is equal to A complement erosion B complement. Proof: by definition of erosion, we have A erosion B complement is equal to set for set such that B set containing A complement. And if B is contained in A, then B intersection A complement is equal to 5. Then the preceding equation becomes A complement is equal to set for set such that B complement is equal to 5 whole complement. But the complement of a set satisfies B intersection A complement is equal to 5. Therefore, thus A minus A erosion B complement is equal to set of B intersection A complement not equal to 5, that is equal to A complement dilation B complement. And next, morphological filtering. In classical signal process, the term filter may mean arbitrary processing procedure. In mathematical morphology, this terminology has a more precise meaning. A morphological filter is an operator that is both increasing and idempotent. Morphological filter preserves ordering relation and converge in a finite number of iterations. The two most important operations are opening and closing. Next, we're discussing the third one, binary opening. The opening of a set A by structuring element B may be defined. A opening B is equal to A erosion B direct sum B. That is, opening A by B is the erosion of A by B followed by dilation of the result by B. And opening generally smoothes the contour of an object, breaks narrow isthmus and eliminates these protrusions. Now next we're discussing physical meaning of opening. The opening operation is a simple geometrical interpretation. Suppose that we view the structuring element B as a rolling ball. The boundary of A is established by the points in B that reach the farthest into boundary of A as B rolled around the inside of this boundary. The geometric fitting property of the opening operation leads to set theoretic formulation, which states that opening of A by B is obtained by taking the union of all translates of B that fit into A. That is, opening can be expressed as fitting process such as A opening B is equal to union of B such that B contained in A. That is in figure 2.6. We can see that structuring element rolling along the inner boundary of next, binary closing. Closing of A by structuring element B is denoted by A dot B, defined as A dot B is equal to A dilated B erosion B, which is in words says that the closing of A by B followed by erosion of a result B, erosion of result by B. In this figure, we can see that the physical meaning of closing. Take the structuring element as here we take the structuring element as a rolling ball. Then the closing A dot B is equal to the points in B that reach farthest into A when B is rolled outside A. Next, we discuss the properties of opening and closing. Opening and closing are dual of each other. That is, A closing A dot B complement is equal to A complement opening B complement. A dot B is A complement A opening B is a subset of A. A is a subset of A closing B. If C is a subset of D, then C opening B is a subset of D opening B. Next, the hit or miss transformation. The Hit-or-miss transformation is a basic tool for shape detection using the morphological erosion operator and pair of distant structuring elements. The result of the hit-or-miss transformation is a set of points where the first structuring element fits the foreground of the input image and second structuring element misses it completely. In figure 2.5.1 discuss the 2.9 discuss the hit-or-miss transformation. Chapter 4 Extension to Grayscale Images. In chapter 2 we discuss the binary image in morphology. Then here we discuss the grayscale images to the morphology. That is, throughout the discussion we deal with the digital image function. Here we use the digital image function f of xy and the structuring element as b of xy. First one, grayscale dilation. Grayscale dilation of f by b denoted by f a dilation b defined as f dilation b of st is equal to maximum of f of s minus x comma t minus y plus b of x y such that x minus x comma t minus y belongs to df of xy belongs to db, where df and db be the domain of f and b respectively. If all the values of structuring element are positive, the output image tends to brighter than input. Second one, the dark details either are reduced or eliminated depending on how their values and shapes related to structuring element used for dilation. In figure 4.1 we can see that f be the simple function and b the height of a be the structuring element. Then after dilation we can see that a height become increased. That is a structure maximum of sum of f and b is the interval spanned by b with the dilation. That is, we can see that the increasing the height. Next, grayscale erosion. Grayscale erosion denoted by f erosion b is defined as f minus b of st is equal to minimum of f of x plus x comma t plus y minus b of xy, where df and db are the domains of f and b respectively. Here we use the same figure function as for point in 1a. Then after eroding we can see that height become decreasing. And in figure 4.3, A be the original image and B be the after dilation and C be the after erosion. In figure we can see that after dilation the image appears brighter than the original and size of dark features such as nostrils and the dark components of the studded rain extending from the ears down to neck have been reduced. In figure 4.3c shows the result of eroding the original image, not the opposite effect of the dilation. The eroded image is darker and the sizes of small bright features were reduced. Next, grayscale opening and closing. The grayscale opening of image f by structuring element b is denoted by f dot b is equal to f dilation b, f erosion b dilated a b. Similarly, the closing of f by b denoted by f dot b is equal to f dilation b followed by erosion b. In figure 4.4 represents the opening and closing of grayscale image. Figure 4.4a shows the result of opening the image of figure 4.3a with the same structuring element used there. Note the decreased size of small bright details with no appreciable effect on the darker gray level. Figure 4.4b shows the closing of figure 4.4a. Note the decreased size of small dark details with a relatively little effect on the brighter features. Chapter 5 Applications of Mathematical Morphology. First, license plate detection. License plate detection LPR is widely used in security and traffic installation. The system used for this purpose consists of illumination, camera, and image processing software used to extract plate information. The LPR system has advantage that system can keep image record of the vehicle, which is useful in order to fight crime and fraud. The LPR system has many advantages like parking, access control, tolling, stolen cars, airport parking, etc. LPR consists of three steps: license plate detection, character segmentation, optical character recognition. Different different operators of different operators of morphology like erosion, dilation, and opening are used for this kind of detection. Next, fingerprint feature extraction. Feature extraction stage is concerned with finding and measuring important similarities of the fingerprint that will be used to match it. Final goal of recognition system is to two fingerprint, one which is already stored in the memory system and other which is captured. Mathematical morphology is used in this extraction purpose. Ridge ending and ridge bifurcation are some problems which occur in fingerprint pattern. Text extraction. Text extraction from images and video sequences finds many useful applications in document processing and detection of vehicle license plate, analysis of technical papers with the labels, maps, charts, and electric circuits, identification of parts in industrial automation, and content-based image or video retrieved from image or video databases. Morphological feature extraction techniques have been effectively applied to character recognition and document analysis, especially if dedicated hardware is used. Next, detection of imperfection in printed circuit boards. Morphological operators like dilation and erosion is also make possible to identify the imperfection of printed circuit boards. The tested image is first converted into binary image, and then morphological operators will apply on tested image and errors will be detected.